Our final speaker of this opening session is Werner Weiss. And after Werner has spoken, there will be a panel discussion which I would ask Dr. Isam to chair. Werner Weiss is director of AEE, Institute of Sustainable Technologies, AEE InTech, in Austria, and is working in national and international solar thermal projects since 1988. He is a board member of the European Technology Platform on Renewable Heating and Cooling and was chairman of the Solar Heating and Cooling Programme of the International Energy Agency, IEA, from June 2010 to May 2014. Since 2007, he has lectured at Vienna University of Technology and is a member of the Scientific Council of EU RAC Research in Italy. Please welcome Dr. Werner Weiss.
Good morning, ladies and gentlemen. Thank you for the introduction. I'm going to show you now in the next 15 minutes what we have on the ground worldwide, what is installed in different countries. We do a study every year for the IEA Solar Heating and Cooling Program now for 12 years already, so it's published every year, and the next edition is going to come by the end of this year. I show you the results of the edition of 2016, which we published just in May of this year. So we cover about 65 countries worldwide in this solar heating and cooling study. I want to start first with an overview on the different renewable energy technologies which are installed worldwide. You can see on the left-hand side in the blue bars the total installed capacity in operation by the end of 2015. It was about 435 gigawatt installed in solar thermal. It's about the same capacity like wind with 433 gigawatt installed capacity, and photovoltaic systems have an installed capacity of around 230 gigawatt installed capacity. This is usually completely different in the political awareness. In the political awareness, it's 90% of the discussion is about wind energy and about PV, and it's underestimated that the biggest capacity in operation is on solar thermal. And then you have geothermal power, solar thermal power, so this concentrating solar systems, it's about 5 gigawatt installed capacity. The red bar shows you the energy supplied by these technologies, and you can clearly see with wind, you can run it if you have wind, a good location where you have windmills, you can run it 24 hours, and this shows you more or less the full load hours. But what I just wanted to mention here at the beginning is the highest installed capacity is on solar thermal heat or heating and cooling. This is the growth rate over the years from 2000 to 2014. As I mentioned before, it's about 430 gigawatt installed capacity, and the related solar energy yield is in the red line. If you look on the market worldwide, so that's China is dominating the market. It's about 70% of the total installed capacity is in China, about 12% is in Europe, and roughly 18% in the so-called rest of the world. And the MENA region accounts for about 1.6%. And this is astonishing because China and also Europe is not known as being in the sun belt of the globe. So it's something behind it, why they use it in these countries and in these regions. It's basically also what Bärbel Epp said before. There were policy support measures behind it. This was mainly the driving force. It was not the source available. But you can imagine in the MENA region, there's the source. You have double the solar radiation usually compared to Europe. That means for the same installation, you get double the output. So there is room for a lot of installations. If you look on the top 10 countries worldwide, then as I mentioned already, China is leading by far. So the the bar goes to the second floor here. We just had to minimize here to get the other countries on it. The different colors show you the different collector technologies. So the blue one is the unglazed water collector, usually used for swimming pool heating. Then you have the orange part, flat plate collectors, and the green are representing evacuated tube collectors. So the top 10 countries, starting with China, then you have in the US a very special market with this mainly focused on pool heating, then Germany, Turkey, and so forth. But these are the 10 leading countries, and most of these countries, or nearly all of these countries, have really political support measures behind it. It's either obligations or other support schemes. So that's usually the driving force. If you look on the top 10 concerning total installed capacity per inhabitant, per 1,000 inhabitants, then it gives you a completely different picture, because this gives you an idea of the market penetration. And then you have Austria. As you know, Austria is not really known as a very sunny country, but we are leading in terms of installed capacity per inhabitant, followed by Cyprus, Israel, Barbados, Greece, the Palestinian territories, Australia, and then you have China on number 8 concerning installed capacity per inhabitant. And I think that gives you a slightly different picture. Coming myself from a small country, I don't like it if you have always the big countries. They're always leading because there are just a lot of people, and also here in Qatar, there's not so many people, but the question is, what is the market penetration per inhabitant? The distribution of the total installed capacity in operation by collector type, again, two completely different pictures. If you look on the worldwide scale, because it's dominated by China, it's 70% is evacuated tube collectors, about 22% is flat plate collectors, and then you have a small share, 6% uncovered, unglazed water collectors, and a few air collectors. If you look just on the European market, it's exactly the opposite. It's 83% is flat plate collectors, small share of 11% evacuated tubes. Distribution by type of collector, again, very different in different regions of the world, economic regions. If you look on the worldwide scale, it's 71% evacuated tube, 22 flat plate, and in the MENA region, it's 92% flat plate collectors and just 7% evacuated tube here in the Middle East and North Africa. By type of system, so generally you have two types of systems. One are the pump systems, so you run a pump in order to get the hot water to the tank, or you have thermosiphon systems, basically driven just by density difference. You don't need additional energy. So that means they are usually used for the small-scale solar water heating systems. And again, here in the MENA region, it's about 61% thermosiphon systems and nearly 40% pump systems. On the worldwide scale, it's 78% thermosiphon and 22% are pump systems. And just a picture of pump systems, so they are usually built on the roof of the houses, or in this picture, it's really the whole south facade is solar collector and also PV in this case, so integrated, and then you have a pump delivering the heat to the storage, or to your cooling machine, for instance, if you use it for cooling. This is a picture from China showing you the thermosiphon system. So there's a lot of these small-scale thermosiphon systems installed on multiple family houses. But in the meantime, of course, in China, there are a lot of really huge centralized systems and pump systems as well. If you look to the distribution by application, then the main application worldwide is 63% is domestic hot water for single family houses, but then about 28% is for multiple family houses and hotels, so in this medium scale, and it's about 2% is for district heating and process heat. And this shows really very positive development, especially this large-scale district heating network, heating and cooling networks in Europe. You can see here about 1 million square meters are installed up to now, and per year at the moment about 20 systems are built every year, and this mainly in Central and Northern Europe. If you look a little bit more in detail, then you can see the leading country here is Denmark, with about 80 systems installed already. So total capacity of nearly 600 megawatt installed. And it's about 10,000 square meter one system, so relatively big systems compared to the second and third country, Germany and Austria, in the range of 25 and 28 systems installed up to now, and the capacity is 30 megawatt. So it's about, on average, about 1 megawatt per system, so significantly smaller compared to the Danish systems. But this is a growing market. And it's just to give you an idea, that's a picture from Weiss in Denmark. It's not the biggest up to now. The collector capacity of 37 megawatt installed capacity, so 50,000 square meter one system. And on the left-hand side, you can see the bit storage. So it stores heat from summer to winter in a huge water storage, and they extract the heat during winter time to use it for space heating. And the even bigger system is under design at the moment. It's a 450,000 square meter system in Austria. So in the design stage, this will be significantly bigger than this one, with about 1.8 million cubic meter of water as a seasonal storage. But it's not just, these systems are not just in Central Europe. We were involved about 5 years ago in Saudi Arabia, in Riyadh. At that time, it was the biggest system worldwide with 36,000 square meters, so 25 megawatt. This system is installed on a flat roof, and it supplies a new part of the city of Riyadh and the Princess Noura University. This is just showing you the short-term storages, 6 times 200 cubic meter. And this is how the collector look if they are not covered, because we had to cover it first, because just to fill the huge system was not so easy in Saudi Arabia. And this is connected also to a district heating in this new part of the city of Riyadh. So district heating and district cooling you can do, of course, also here in the region. As I said, 5 years ago, it used to be the biggest system worldwide. It was mentioned already yesterday by Daniel Mounier. The cooling systems in operation worldwide, it's about 1,200 systems, so it's an early stage compared to the overall cooling market worldwide. And very important also, global process heat. So applications here, there's a huge potential. There's a lot of food and beverage industry, but also mining industry, where there's a huge potential for heat and cooling, of course, as well. So in the large system range above 1,000 square meters, we have documented about 21 systems worldwide. Then in the range between 500 and 1,000 square meter systems, 35, and so forth. You can, if you want to have a look in detail, we have a very nice database for all these systems worldwide, where you find it, all the details. This is just at the moment the biggest one, the copper mine in Chile. So it's also in the Atacama Desert, where they use these collectors in the copper mining field for electrowinning and the leaching process. And I think that's really important. In these regions, there's plenty of sunshine, there's mining industry, and they need low temperature heat. And unfortunately, I don't have a picture here. There's a big system under construction at the moment from the company GlassPoint, on concentrated system for enhanced oil recovery here in the region. The number of jobs, finally, there's quite big number of people working in this field. It's 730,000 people working worldwide in the production, installation, and maintenance of solar thermal systems. And also the turnover, I think, is quite good in the meantime, 21 billion euro or 24 billion US dollars. So it's a significant turnover of the solar thermal industry. And with this, I hope I could give you an overview on solar heating and cooling technologies, what's on the ground. And hopefully you're eager to install some more of these systems also here in the region. And with this, I thank you for your attention.